Today we are going to be looking at the Bridge Builder program that you're going to be using for your bridge projects, and I wanted to record a quick tutorial on how to operate the program, some of the features of the program, and the basics of designing a bridge. So you all should have downloaded and installed the Bridge Design program, and I did ask that you pin that to either your start menu or your taskbar or both. So if you've completed those steps by now, then what you'll need to do is open up the Bridge Design program, and we'll go from there. So mine's already onto my taskbar here, and I'm using the Bridge Designer for older computers because I want to make sure that my graphics work and it doesn't just freeze up on me. So I click there and the Bridge Design program opens up. The design tip of the day usually gives you some piece of useful information to help you with your bridge project. After you've read all of them, you can feel free to close the start tips and they won't show up anymore. So I'm just going to close out there. We are creating a new bridge design, so I'm going to click OK. And here I'm reading the design requirement. Okay. So the first design requirement is to design a bridge that can carry its own weight and include the weight of a road deck where cars and trucks would drive on, plus the weight of a standard truck. The load is the entire amount of weight that the bridge must be able to support without failing, without collapsing. So that's the first part of the requirement. Second is to keep the cost of the project as low as possible. So again, we have a budget that we have to worry about. Anybody can build a bridge, that'll support weight. The trick is to be able to build one that just barely supports the weight you want at a cost that's quite affordable. Also over here on the right hand side you see a design tip. So make sure that you read these each time that you start a new bridge. Right now our site cost is 0 because we're just getting started, and we move on to step 2, which is a contest code. We are not taking part in a code, so make sure that no is always checked. Step 3 is to select our elevation. For our very first bridge, I'm going to keep it pretty simple. I want you to go from 24 meters, and I want you to set your bridge height at 8 meters. Notice that it lowers the bridge here. It also increases the site cost because now you have to remove all of this dirt to get your bridge ready. So that's going to be a cost automatically added onto your budget. We are using standard abutments, which means that we are supporting our bridge from the very ends of the bridge only. We are not using any piers. We're making single span bridges, and we have no cable anchorages. I then go to next. I'm going to use medium strength concrete for my first bridge. I'm also going to use the standard truck loading. We're not going to make this too complicated. So that's all set, and I click next. Today I'm going to use a template to help me out. Notice that each truss has a different name, named after the people that designed them. The Howe truss looks like what's shown in the picture. The Pratt truss looks a little bit different. The Warren truss looks different still. These through trusses all show up above the roadway. The deck truss appears below the roadway. For our bridges we build in class, we're always designing through trusses because that's what we will build in class. So make sure you're always selecting that. So pick one of the 3 that you would like to work with today and go from there. I'm going to stick with Howe because it's the first one on the list. I don't need to do anything here. Changing the name or anything is not necessary. So I click next, and I'm going to look at the design instructions. Click finish to activate the drawing board. First draw joints, which we'll talk about in a moment. Then draw members. Load the test to see if it works. Strengthen anything that's weak. Optimize the design by then shrinking the cost, and then ultimately I should be finished. So first thing I'll do now is click finish, and here is my bridge design screen. Joints. I'm going to look up here in my little tools section. Joints are where sections come together. So I'm going to select the joint tool, and since I have the template ready, it's got a gray location for everything. So I'm going to put a joint everywhere I see a circle on the template. And that's all of those. Now I don't have to do it on the ones on the bottom because they're already there. They will always be installed there. From there, I connect the joints with members. Bridge members are the strong pieces of steel that kind of hold it all together. They connect all the joints, and the joints connect the members. So I can go piece by piece by piece, just like this. Or if I want to speed up my process, I click and hold and drag through the dots, and it connects all of them. Notice over here, every member I'm putting on my design shows up on my member list. So I'm going to really quickly here finish connecting all the joints together with members, following the template design that is outlined on the screen. Okay, so now my bridge design is finished. I can do a few things here if I wanted to test it or change something, but one neat little trick is, notice the words in the middle of your bridge, they're kind of in the way. I'm just going to hover over them until I see the arrows. I'm going to drag them down below so that way they're not in front of my design. It's kind of a nice little trick. Okay, so I'm going to test my bridge. I'm on drawing board right now. I want to switch to test. I click test and it runs through the animation. Oh no, my bridge failed because the truck is too heavy for my bridge supports. If I go back and I reset my animation, I can play it in slow motion here, and I can see what's wrong is as soon as the truck gets on there, this member here turns really red and then collapses. The red and the blue are stresses, and the stress is in the form of compression and tension. So I'm going to go back to the drawing board to see what went wrong. Here I have a compression force on the first beam. It's shown in red. That beam received a compression force of 1.02. Other beams had no compression forces. Others had somewhere less than 1. Everything that was less than 1, though, didn't fail. So I need to strengthen this member. I'm going to increase its size. So what I want to do is I want to click on the member here on the diagram, or if I wanted to, I could click over here on the member list, and it highlights different members that I want to work with. So that's the one that failed. I want to make it bigger. So I'm going to go up here to the member size. It's 140 by 140 member, and I want to make it a little bigger. I'm going to go up to, let's make it really strong. Let's go to 160 by 160. Now I don't know if that's going to work or not because I've made a change. I know it failed last time. It's still highlighted in red there, but I'm going to run the test to see if it holds up this new next time. See the red compression forces. See blue tension forces. Here comes the truck. Truck's going on. It's turning red. A little darker red. A little darker red. Really red in the middle. But it's not failing. Looks like the truck's going to make it. So really red means there's a lot of force there, but if it doesn't fail, then the bridge will be strong enough. So really red and really blue are not necessarily bad things, but it does tell you where you got a lot of force. So as I go back to the drawing board, I take a look at my numbers. That first one I changed now has a compression force of 0.6, which was a little more than half of what it had before, but it's plenty strong. As I look here, there was one bar, 16. That was that center bar that was really red. That got up to 0.87, so it's getting really close to 1. I have a feeling that anything over 1 is going to fail for me. Well, I got a bridge that's strong enough. Now I look at my budget. My budget right now is $284,000 and some change. Now I want to see if I can lower the cost of that bridge by changing other structures. So like for example, let's go to one here, that one we changed, that 0.61. We jumped up a few. Let's go to 150 by 150. Lowered the cost a little bit, but let's see if it's strong enough. Run the test animation. Yes, it was plenty strong that time. So it worked. Lowered the cost a little bit, but it's still strong enough to support the bridge. So I can go back and I can change as many members as I want. So if I want to change this one here, it's a 0.43. Maybe I can make it thinner. Let's go 100 by 100. See if that works. Run my test. No, that's not gonna work. It's just too thin. So I go back here. 100 by 100 is not big enough, and I can start testing one notch at a time. These little buttons here go up one notch bigger, one notch smaller, and those are ways to make easy little quick changes. So I run my test, make it one notch bigger. Is it going to work? Yes, it worked. So I know that that is the smallest this bar, this piece, can be and still get the job done. I've lowered my cost a little bit, but I've maintained the strength. So now what I want to do is continue to work with each of my bars to get this cost as low as I possibly can. So for your first bridge today, I want you to use the same settings I did. If you don't remember, go back to the beginning of the video. And I want to see how low you can get your bridge cost using the How Truss today. I'm going to use the How Truss for everybody. When you're all finished, at the end of the class period, I want you to take a snip of your screen. Everything that's on the screen right now on my screen should be on your snip. I want to see the budget. I want to see that your bridge is strong, it's been tested, and you'll turn that in on Canvas. If you have any questions, just be sure to ask. Don't get too frustrated. Just keep working at it piece by piece and keep testing, testing, testing. Good luck, and I look forward to seeing what you have.